April 1, 1945. The largest amphibious assault in Pacific theater history crashes onto Okinawa's beaches. American 6th Army and Marine Forces pour ashore under Lieutenant General Simon Bolivar Buckner, Jr. The goal is brutal arithmetic. Seize the last major stronghold before Japan itself. But hidden among the standard-issue M1 Garands and Thompson submachine guns, 150 soldiers carry weapons that look like science fiction made real. The U.S. Army T3 Carbine with T120 infrared sniperscope. For the first time in human warfare, American troops can see in complete darkness and kill what they see. The Japanese 32nd Army under Lieutenant General Mitsuru Ushijima has no idea what is coming for them in the night. The weapon changes everything. Within the first week of the Okinawa campaign, 30% of all Japanese casualties inflicted by American rifle and carbine fire come from these 150 infrared-equipped carbines. Not from the 180,000 invasion troops. Not from the massive artillery bombardments or naval gunfire. From 150 men with rifles that turn night into day, wielding what their fellow soldiers call Buck Rogers ray guns. The story begins 2 years earlier, in the steaming jungles of Guadalcanal and New Guinea, where American soldiers learned to fear the darkness. Japanese infiltration tactics had terrorized Allied forces across the Pacific. Small teams of Imperial soldiers, armed with nothing more than Arisaka bolt-action rifles, bayonets, and grenades, would slip through American lines under cover of night. They moved like ghosts through the jungle, striking at command posts, cutting communication lines, and vanishing before dawn. The psychological impact was devastating. American troops, exhausted from daylight combat, found no rest after sunset. Technical Sergeant William Morrison of the 32nd Infantry Division later described the terror. You'd hear them moving out there in the dark, rustling in the leaves, maybe a twig snapping. You couldn't see a damn thing, but you knew they were coming. Sometimes they'd just lie there for hours, waiting for you to fall asleep. Then you'd wake up to find your buddy's throat cut in the foxhole next to you. The Japanese had perfected these tactics through years of fighting in China and Manchuria. Imperial Army training emphasized night operations, and soldiers practiced moving silently through rough terrain for hours. They learned to navigate by starlight, to distinguish between natural sounds and enemy movement, and to strike with maximum psychological impact. A single Japanese soldier, properly trained and equipped, could terrorize an entire American company through a long Pacific night. By 1943, the pattern had become predictable and deadly. American forces would advance during the day, taking objectives with superior firepower and air support. But when darkness fell, the battlefield belonged to Japan. Small groups of Imperial soldiers would infiltrate American positions, plant mines, cut telephone wires, and eliminate sentries. Even when these raids failed to inflict significant casualties, they shattered American morale and left entire units sleepless and combat ineffective. The Army Engineer Board at Fort Belvoir, Virginia, received an urgent directive: develop a solution to Japanese night infiltration. The challenge seemed impossible. How do you give American soldiers the ability to see in complete darkness? The technology barely existed, confined to laboratory experiments and theoretical papers. But by late 1943, civilian researchers at the Electronics Laboratory had assembled the components of a working system. The breakthrough came from combining 3 existing technologies: an infrared spotlight, similar to a car headlamp but filtered to emit only invisible infrared radiation, an electronic image converter that could translate infrared light into visible green images, and a portable power source capable of generating the high voltage needed to operate the system. The result was the T120 infrared sniperscope, a device that could reveal human figures in complete darkness at ranges up to 70 yards. The engineers needed a weapon to mount the scope on. The M1 Garand rifle was too heavy and cumbersome for the delicate electronic equipment. The Thompson submachine gun lacked the accuracy needed for precise night shooting. But the M1 Carbine, weighing just 5.5 pounds with its .30 caliber cartridge and 18-inch barrel, provided the perfect platform. Semi-automatic fire, manageable recoil, and a size that wouldn't overwhelm the infrared system. Winchester, Inland Division, and other manufacturers had produced over 6 million M1 carbines by 1945, making it the most produced American small arm of World War II. The weapon had armed everyone from paratroopers to tank crews, from Filipino guerrillas to rear echelon personnel. Its gas-operated rotating bolt system proved reliable in the humid conditions of the Pacific, and its non-corrosive primer ammunition resisted the barrel corrosion that plagued .30-06 weapons in tropical environments. But the T3 carbine represented something entirely new. Engineers modified the M1 carbine receiver to accept an integral scope mount, eliminating the iron sights entirely. The infrared scope, designated T120, mounted on top with a large infrared spotlight positioned beneath the barrel. A power cable snaked from the scope to a canvas backpack containing a 6-volt lead-acid battery and a vibrator transformer that stepped the voltage up to the 4,250 volts required by the image converter tube. The complete system weighed 34 pounds. The soldier carrying the T3 carbine also hauled the battery pack, while a second soldier typically carried spare batteries and provided security. The infrared spotlight could illuminate targets up to 70 yards away, and the scope revealed them as ghostly green figures moving through the electronic twilight. For the first time in human history, darkness was no longer an absolute sanctuary. William W. Garstang, one of the electronics laboratory personnel involved in T120 development, later wrote that his company produced 1,700 infrared scopes during World War II. All were destined for either Okinawa or the Philippines. The Army designated teams of 2 or 3 soldiers to operate each system, one to carry and fire the weapon, one to carry spare batteries and provide support, and sometimes a third to serve as security and communication link. Training proved crucial. The infrared scope displayed a green-tinted image with limited depth perception and a narrow field of view. Operators had to learn to distinguish between vegetation moving in the wind and human figures creeping through the undergrowth. They practiced tracking moving targets and compensating for the carbine's trajectory at night fighting ranges. Most importantly, they learned to coordinate with conventional forces to avoid friendly fire incidents. The T3 carbine teams deployed to Okinawa in April 1945, scattered among Army units preparing for what military planners knew would be a vicious campaign. Intelligence reports indicated that Lieutenant General Ushijima had fortified the island with 77,000 Japanese troops, including seasoned veterans from the Guandong Army in Manchuria. These forces had constructed an elaborate defensive network of caves, tunnels, and mutually supporting strongpoints designed to bleed American forces white. Ushijima's defensive strategy relied heavily on night operations. During daylight hours, Japanese forces would hunker down in their fortified positions, weathering American artillery bombardments and airstrikes. But after sunset, small teams would emerge to harass American positions, lay mines, and conduct raids. The 32nd Army had practiced these tactics extensively, and many of its soldiers had experience in night fighting from campaigns in China and Southeast Asia. The Japanese commander understood that he could not stop the American invasion through conventional defensive tactics. His forces were outnumbered more than 2-1, and American firepower superiority was overwhelming. But if he could drag out the campaign through effective night harassment, inflicting steady casualties and breaking American morale, he might force the United States to reconsider its plans for invading Japan itself. On the night of April 6, 1945, Japanese forces launched their first major infiltration attempt against American positions on Okinawa. Small teams of Imperial soldiers, armed with Arisaka rifles, Type 97 hand grenades, and satchel charges, crept toward the American perimeter. They moved with the confidence born of 2 years of successful night operations across the Pacific. In previous campaigns, this same tactic had terrorized American forces from Guadalcanal to the Philippines. But this time, the darkness betrayed them. Private First Class Robert Chun of the 96th Infantry Division crouched behind his T3 carbine, scanning the terrain through the infrared scope. The green-tinted display revealed what his naked eye could never see: 3 Japanese soldiers crawling through tall grass 200 yards to his front. He watched them approach, noting their weapons and equipment, waiting for them to enter the 70-yard effective range of his system. The lead Japanese soldier rose to a crouch, signaling his companions to advance. Chun centered the scope's reticle on the figure's chest and squeezed the trigger. The .30 caliber cartridge fired with a muffled report, the T-23 flash hider concealing the muzzle flash that might have revealed his position. Through the scope, he watched the Japanese soldier collapse. The other two figures froze, confused and disoriented by the sudden death of their leader. Chun fired again and again. Both remaining infiltrators fell within seconds. For the first time in Pacific warfare, Japanese soldiers had been killed by an enemy they could not see, could not locate, and could not fight back against. The age of night vision warfare had begun. Similar scenes played out across the American perimeter that night. T-3 carbine operators, positioned in concealed defensive positions, picked off Japanese infiltrators with mechanical precision. The infrared scopes revealed approaching enemy soldiers as clearly as if they were silhouetted against a bright sky. American troops, who had endured 2 years of terror from invisible nighttime attackers, suddenly held the advantage. Staff Sergeant Michael Rodriguez of the 7th Infantry Division later described the psychological impact. It was like watching a movie, these green figures moving around in the scope, thinking they were invisible, thinking they owned the night. Then you'd fire and they'd just drop. Word spread fast that we had some kind of secret weapon. The guys started calling us the Ghost Killers. The effectiveness of the T-3 carbine exceeded all expectations. During the first 7 days of the Okinawa campaign, these 150 infrared-equipped weapons accounted for approximately 30% of all Japanese casualties inflicted by American small arms fire. This represented a kill ratio unprecedented in military history. Roughly 1/50th of American infantry weapons were responsible for nearly 1/3 of enemy rifle casualties. Lieutenant Colonel James Patterson, operations officer for the Ziv Corps, filed a report that captured the strategic significance. The psychological effect on enemy night infiltration attempts has been decisive. Japanese forces appear to have lost confidence in their ability to operate effectively during hours of darkness. Previously reliable tactics have been abandoned, and enemy activity after sunset has decreased markedly. From the Japanese perspective, the experience was terrifying and incomprehensible. Sergeant Hiroshi Tanaka of the 62nd Division survived one of the early infiltration attempts and later recounted his experience to American interrogators. "We moved as we had always moved, silent and invisible in the darkness. But the Americans could see us somehow. They fired with perfect accuracy from positions we could not locate. It was like fighting demons who could see through the night itself." Japanese commanders struggled to understand what they were facing. Radio intercepts revealed confusion and fear among Imperial units attempting night operations. Some reports spoke of American soldiers with magical vision or devil eyes. Others theorized that the Americans had developed a new type of artillery with pinpoint accuracy. The truth that individual American soldiers could see and kill in complete darkness seemed beyond comprehension. Intelligence personnel within the 32nd Army attempted to develop countermeasures. They experimented with smoke screens and diversionary attacks designed to confuse the mysterious American night vision capabilities. Some units tried approaching American positions from multiple directions simultaneously, hoping to overwhelm whatever detection system the enemy was using. Nothing worked. The T-3 carbine operators developed their own tactics as the campaign progressed. They learned to coordinate with conventional forces, using radio communication to direct artillery fire onto larger Japanese formations that appeared in their scopes. They practiced rapid position changes, moving immediately after firing to avoid counterattack. Most importantly, they learned to use their unique capability as a force multiplier, providing early warning and precise targeting information to support larger defensive operations. Technical challenges emerged as the campaign continued. The electronic components of the T-120 scope proved vulnerable to moisture and shock. Fog and rain degraded the infrared system's effectiveness significantly. The heavy battery pack limited mobility and made rapid position changes difficult. Operators learned to carry multiple spare batteries, as the power-hungry system drained its 6-volt source within a few hours of continuous operation. But these limitations paled beside the weapon's revolutionary impact. For the first time in the Pacific War, American forces could effectively contest Japanese control of the night battlefield. the psychological advantage that Imperial forces had enjoyed since Pearl Harbor evaporated. Night infiltration, the tactic that had terrorized American troops from Guadalcanal to the Philippines, became a death sentence for Japanese soldiers. The broader implications extended far beyond Okinawa. Military planners recognized that night vision technology would fundamentally alter the nature of warfare. If individual soldiers could see and fight effectively in complete darkness, traditional concepts of defensive perimeters and safe rear areas would become obsolete. The nation that mastered night vision technology would hold a decisive advantage in future conflicts. American industry responded to the potential. The Electronics Laboratory, which had struggled to produce 1,700 infrared scopes during the war, received contracts for thousands more units. Plans emerged for equipping entire divisions with night vision capabilities. Research programs began developing improved systems with longer range, better image quality, and reduced weight. The Japanese, meanwhile, found themselves technologically outmatched once again. Throughout the Pacific War, American industrial capacity and technological innovation had steadily eroded Japanese advantages. The Zero fighter, once supreme in Pacific skies, had been surpassed by American aircraft. Japanese naval forces, crippled at Midway and the Philippine Sea, could no longer contest American naval supremacy. Now, even the night battlefield, the last domain where Japanese forces could operate on equal terms, had fallen to American technological superiority. Intelligence reports from captured Japanese documents revealed the devastating impact on Imperial morale. One document, found in the headquarters of the 24th Division, described American night fighting capabilities as supernatural and incomprehensible. Another report, from a battalion commander in the 44th Independent Mixed Brigade, recommended abandoning night operations entirely. The enemy possesses the ability to see and kill in complete darkness. Our soldiers fear to move after sunset. The success of the T3 carbine at Okinawa validated a broader American approach to warfare that emphasized technological solutions to tactical problems. Rather than matching Japanese night fighting skills through intensive training and specialized tactics, American engineers had developed a technological edge that rendered those skills obsolete. This pattern, using industrial and scientific superiority to overcome enemy tactical advantages, would become a hallmark of American military doctrine. Production data reveals the scale of American commitment to night vision warfare. By war's end, approximately 1,900 T3 carbines had been manufactured, along with thousands of spare scopes and battery packs. Plans existed for producing 20,000 complete systems, enough to equip significant portions of the Army and Marine Corps. Only the Japanese surrender in August 1945 prevented this massive expansion of night vision capabilities. The technological lineage of the T3 carbine extended directly to modern night vision systems. The basic principle, using infrared illumination and electronic image conversion to create visible images from invisible light, remains fundamental to contemporary night fighting equipment. While modern systems are smaller, lighter, and more capable, they trace their ancestry directly to those 150 carbines that changed warfare at Okinawa. Individual accounts from T3 operators provide insight into the human dimension of this technological revolution. Corporal David Kim of the 27th Infantry Division kept a diary during the Okinawa campaign, April 15, 1945. Spotted 6 enemy soldiers moving toward our position at 0230 hours. Range approximately 50 yards. Engaged and eliminated all targets with 8 rounds. No American casualties. It still seems impossible that we can do this. Private Ronald Martinez of the 96th Infantry Division wrote to his family, "I can't tell you much about what I'm doing, but I can say that we have a new weapon that lets us see in the dark. The Japanese don't know what hit them. For the first time since I've been in the Pacific, I'm not afraid of what's coming in the night." The psychological transformation was complete. American soldiers, who had endured years of terror from Japanese night infiltration, suddenly found themselves holding an overwhelming advantage. The weapon that had seemed like science fiction became a tool of psychological warfare as powerful as any explosive device. Japanese commanders attempted to adapt their tactics to the new reality. Some units shifted to daylight operations, accepting the increased vulnerability to American artillery and air power. Others experimented with long-range harassment, using mortars and light artillery to attack American positions from beyond the 70-yard effective range of the infrared scopes. But these adaptations came too late and proved insufficiently effective. The broader strategic impact extended beyond the Okinawa campaign itself. Military planners preparing for Operation Downfall, the planned invasion of Japan, incorporated lessons learned from T3 Carbine operations. They anticipated that Japanese forces would rely heavily on night infiltration tactics to defend their homeland, and they planned to deploy thousands of infrared-equipped carbines to counter these operations. Intelligence estimates suggested that American night vision capabilities would prove even more decisive in the confined terrain of the Japanese home islands. Urban warfare, in particular, would favor forces capable of seeing and fighting effectively in darkness. The psychological impact on Japanese civilian morale, already strained by years of bombing and privation, might prove overwhelming when combined with the knowledge that American forces possessed supernatural night fighting abilities. The atomic bombings of Hiroshima and Nagasaki, followed by Japanese surrender, prevented this ultimate test of night vision warfare. But the precedent established at Okinawa demonstrated the revolutionary potential of the technology. In 82 days of fighting, 150 infrared carbines had fundamentally altered the tactical balance and contributed significantly to American victory. Post-war analysis confirmed the weapon's impact. Japanese survivors consistently identified American night vision capabilities as one of the most demoralizing and tactically significant developments of the Okinawa campaign. Colonel Hiromichi Yahara, senior staff officer of the 32nd Army, wrote in his post-war memoir, "The Americans' ability to see and kill in darkness represented a technological superiority that rendered traditional Japanese tactics obsolete. Our soldiers lost faith in their ability to fight effectively under cover of night." The legacy of the T3 carbine extended far beyond World War II. Improved versions saw service in Korea, where they proved effective against Chinese and North Korean infiltration tactics. The basic technology evolved into the night vision systems that became standard equipment for American forces in Vietnam, Iraq, and Afghanistan. Today, night vision capability is considered essential for modern infantry operations, a direct descendant of those first 150 carbines that illuminated the darkness at Okinawa. The human cost of Japanese night infiltration tactics, suffered by American forces throughout the Pacific War, cannot be quantified precisely. But the psychological trauma inflicted by invisible enemies striking from the darkness affected thousands of soldiers. The T3 carbine represented more than a technological advancement. It provided psychological liberation from one of warfare's most primal fears. Technical specifications of the complete T3 system reveal the engineering challenges overcome by American researchers. The T120 infrared scope required 4,250 volts to operate its image converter tube. The 6-volt battery pack used a vibrator transformer system to generate this high voltage, a mechanism that added weight and complexity but proved reliable under combat conditions. The infrared spotlight, filtered to emit only invisible radiation, could illuminate targets clearly while remaining undetectable to the naked eye. The scope's green-tinted display became iconic among soldiers who operated the system. Objects appeared in various shades of green and black, with human figures standing out clearly against most backgrounds. The narrow field of view required operators to scan systematically, but the image quality was sufficient for accurate shooting at the weapon's maximum effective range. Training protocols developed for T3 operators emphasized both technical proficiency and tactical integration. Soldiers learned to maintain the delicate electronic equipment, change batteries under combat conditions, and coordinate with conventional forces. They practiced target identification, distinguishing between enemy soldiers and friendly personnel moving in the darkness. Most critically, they learned to exploit their unique advantage while avoiding the technological limitations that could prove fatal. The Electronic Laboratories production records show the rapid scaling of infrared scope manufacturing. Initial prototype production began in 1943, with fewer than 50 scopes completed. By 1944, monthly production reached several hundred units. The facility's total output of 1,700 wartime scopes represented a remarkable achievement for a technology that had existed only in theoretical form just 2 years earlier. Field maintenance of the T3 system required specialized knowledge and equipment. The image converter tube, the heart of the infrared scope, was particularly fragile and expensive. Replacement tubes had to be shipped from the United States, creating logistical challenges in the remote Pacific theater. Battery maintenance proved equally critical, as the lead-acid power sources deteriorated rapidly in tropical conditions. Despite these challenges, the T3 carbine's combat effectiveness made it one of the most successful weapons innovations of World War II. The kill ratio achieved by infrared-equipped carbines exceeded that of any other individual weapon system. The psychological impact on enemy forces proved equally significant, breaking the Japanese monopoly on effective night operations. Intelligence analysis of captured Japanese documents revealed the enemy's desperate attempts to understand and counter American night vision capabilities. Some reports speculated about new forms of radar or sound detection equipment. Others theorized that American soldiers had been given drugs that enhanced their natural night vision. The reality that electronic technology could create artificial sight in complete darkness seemed beyond Japanese comprehension. The strategic implications extended to post-war military planning. American defense planners recognized that night vision technology would become increasingly important as potential adversaries developed their own infrared capabilities. Research programs begun during World War II evolved into the comprehensive night vision systems that became standard equipment for American forces in subsequent conflicts. Manufacturing data from the war's end reveals the scale of planned expansion. Contracts existed for producing 20,000 complete T3 systems, enough to equip significant portions of the Army and Marine Corps. Additional contracts covered spare parts, replacement scopes, and improved battery systems. Only the sudden end of the war prevented this massive increase in night vision capabilities. The T3 carbine operators who fought at Okinawa became pioneers in a new form of warfare. Their experiences, documented in after-action reports and personal accounts, provided the foundation for modern night fighting doctrine. The tactics they developed coordinated with conventional forces, rapid position changes, and systematic target engagement became standard procedures for night vision-equipped troops. Environmental factors significantly affected T3 operations at Okinawa. Rain and fog degraded the infrared system's effectiveness, forcing operators to adapt their tactics to weather conditions. High humidity caused corrosion problems with electrical connections. Dust and debris from artillery bombardments could damage the delicate scope mechanisms. Despite these challenges, the system's combat effectiveness remained superior to any alternative available. The broader technological context of World War II provides perspective on the T3 carbine's significance. While radar, sonar, and nuclear weapons received more attention, the development of practical night vision technology represented an equally important breakthrough. For the first time, individual soldiers could extend their effective fighting capability into the hours of darkness that had traditionally belonged to specialized troops or elite units. Combat reports from Okinawa consistently emphasized the psychological impact of the T3 carbine on both American and Japanese forces. American soldiers, previously terrorized by invisible nighttime attackers, gained confidence and combat effectiveness. Japanese forces, accustomed to owning the night battlefield, found their most reliable tactics suddenly suicidal. This psychological transformation affected the entire character of the Okinawa campaign. The technical challenges overcome in developing the T3 system demonstrate American industrial and scientific capabilities during World War II. Creating a practical night vision weapon required advances in electronics, optics, battery technology, and manufacturing techniques. The speed with which these challenges were resolved and the technology deployed to combat units reflects the effectiveness of American wartime research and development programs. Individual weapon effectiveness statistics from Okinawa reveal the T3 carbine's exceptional performance. While exact numbers vary depending on the source, most estimates suggest that each infrared-equipped carbine eliminated enemy personnel at rates far exceeding conventional weapons. This effectiveness ratio justified the system's complexity and cost, validating the American approach of using technological superiority to achieve tactical advantages. The aftermath of the Okinawa campaign saw intensive analysis of T3 carbine performance. Military researchers interviewed operators, studied combat reports, and analyzed captured Japanese documents to understand the weapon's impact. Their findings influenced post-war development of improved night vision systems and shaped American doctrine for night combat operations. Manufacturing records from Winchester, Inland Division, and other carbine producers show the integration of T3 production into existing weapons manufacturing. The modified receivers required additional machining operations, but the basic carbine production lines could accommodate T3 requirements without major retooling. This manufacturing flexibility enabled rapid scaling of production when combat effectiveness was demonstrated. The T3 carbine's role in the broader context of American weapons development during World War II demonstrates the nation's ability to innovate rapidly under wartime pressure. From the M1 Garands' semi-automatic capability to the T3's night vision technology, American weapons designers consistently stayed ahead of enemy developments. This technological edge proved decisive in multiple theaters and campaigns. Final combat statistics from Okinawa confirm the T3 carbine's revolutionary impact. In a campaign that cost the United States over 49,000 casualties and Japan approximately 77,000 military dead, the contribution of 150 infrared-equipped carbines was disproportionate to their numbers. Their 30% share of Japanese rifle casualties, achieved with less than 1% of American small arms, represents one of military history's most effective weapon deployments. The technology that began as a desperate response to Japanese night infiltration tactics evolved into a fundamental capability of modern military forces. Every soldier today who operates with night vision equipment, from Afghanistan to training ranges across America, traces their lineage back to those first 150 T3 carbines that changed warfare in the darkness of Okinawa. The Japanese had owned the night for 3 years of Pacific fighting. In 82 days on a small island, American technology took it away forever.